Hi everyone, I'm Jessica VASU. My matrix number is 23DBT 20F 2019 and I'm from Polytechnic Nilai Negeri Sembilan. Today, we are going to see the Pcr Primer Design Interactive for my DYB 30093 Molecular Biology subject. So let's get started. PCR is a powerful lab technique used to generate billions of copies of a specific sequence of DNA. Having many copies of particular sequences allows you to read, compare, and manipulate them, which is useful in many fields. To conduct a successful PCR reaction, it is necessary to have the precise nucleotide sequence of the starting and ending regions of the DNA that needs to be amplified. Knowing the DNA sequence is necessary to design a set of two short pieces of DNA called primers that specifically recognize the region you want to amplify. These primers anneal to the two anti-parallel DNA template strands and serve as the start of DNA synthesis by the enzyme DNA polymerase. Designing primers for a PCR reaction is an important step because the way they bind to the template DNA dictates much of the success of the PCR reaction. What are the rules for primer design? Primers are chosen to anneal to each of the template strands at locations that define the start and the region to be amplified. The three ends of the primers point at each other. The primer that anneals to the bottom strand DNA is called the forward primer. Its sequence is identical to the loop strand and can easily be read forward from 5 to 3. The primer binding to the top strand is called the reverse primer. The sequence of the reverse primer is identical to the bottom strand in the 5 to 3 orientation. Primers define where the amplification begins. They will be part of the final PCR product. We will come back to the reverse primer later. The sequence of the former primer is identical to the top strand at the beginning of the region to amplify. 3 direction. The primer binds or anneals to a specific sequence in the rules of complementary base pairing. Guanines bind to cytosines with 3 hydrogen bonds, whereas adenines form 2 hydrogen bonds to thymines. PCR primer should have an annealing region between 16 to in our example, the sequence of the forward primer is identical to the first 21 nucleotide of the region to amplify. Longer primers anneal with greater specificity to the correct template sequence, but the annealing step takes more time. The extension of the primer by Taq polymerase, the actual DNA synthesis, takes place on the primer's 3 end. To ensure optimal elongation, the last 5 bases at the 3 end should be an exact match with the DNA template and contain at least 2 guanines or cytosines. Primers are not always exactly complementary to the template. For example, matches are tolerated as long as the surrounding primer regions anneal well. That can be used to introduce sequence changes or mutations. The reverse primer anneals to the top strand by nucleotide base pairing, just like the former primer annealed to the bottom strand. The sequence of the reverse primer is identical to the bottom DNA of the appropriate region. By convention, primers are always designed in the 5-to-3 orientation. The sequence of the reverse flipped to primer to adhere to this convention, which facilitates comparing primers and ordering them for companies. Some primers anneal more stably to the template than others. In addition to the length of the primer, its nucleotide sequence determines the binding. The bases D and C form 3 hydrogen bonds, where A and T only form 2. Therefore, a primer with a high GC content binds more strongly to the DNA template than a primer with a high AT content. To promote stable annealing to the primer to the DNA template, the GC content should ideally be between 40 and 60%. The GC content has to be taken into consideration when determining the annealing temperature used for the cycles of a PCR reaction. Primers with higher GC content anneal to the template more stably and dissociates at higher temperature. For example, an 18 nucleotide long primer completely consisting of G and C has a melting temperature of 89 degrees Celsius at a concentration of 500 nanometer. In contrast, a primer of the same length and concentration consisting exclusively of A and T has a melting temperature of 38 degrees Celsius. The melting temperature of DNA is defined as the temperature at which 50% of the double-stranded DNA is disassociated into single strands. Shown here are melting temperatures of two primer template complexes, with the two primer having differing GC content and hence different melting temperatures. In our case, the forward primer has a lower GC content, so its length has been increased in order to increase its melting temperature to match that of the reverse primer, which is more GC rich. The melting temperature of both primer is now the same, 68 degrees Celsius. Once the primer sequences are designed, we can order the primer to be synthesized by a company. After receiving our design primer set, we can set up our PCR reaction and program the PCR mission. The programming of the PCR mission or thermocycler follows the cyclical PCR steps of DNA denaturation, primer annealing, and elongation. The denaturation step is usually 30 seconds long at 95 degrees Celsius to ensure complete dissociation of all DNA strands. The annealing temperature depends on the sequence of the two primers. In our case, the suggested annealing temperature is 64 degrees Celsius, a few degrees lower than the primer melting temperature to increase the probability of primer binding. The annealing step lasts for 30 seconds before the thermocycler initiates the last step, elongation. After annealing, the primers are extended by Taq polymerase along the DNA template at 72 degrees Celsius, which is the optimal temperature for the polymerase. The time for this phase of DNA synthesis depends on the length of the desired PCR product, but the usual elongation time is 1 minute per 1000 bases of PCR product. These three PCR steps are generally repeated 30 times to create over a billion copies of the desired DNA region. After the PCR machine completes the 30 cycles, it is automatically set to 4 degrees Celsius to keep the PCR products cool and stable. That's all from me today. Thank you very much for watching.